Okay, well, thank you. So first of all, I must start with the disclaimer that I am not Venkat Achanta. And so we did invite him. We are an Arkansas company, Black Oak Analytics, and a sponsor here at CDO. And something very urgent came up at the last minute, so I'm in this very uncomfortable position of not only filling in for someone at Walmart, but following Michael Stonebreaker. So I'll try to do the best I can. We are very fortunate that we've got a lot of great data companies in Arkansas, a lot of great corporations. I consider Walmart a great data company. I mean, it's, somebody said it was a data company that decided to go in the retail business. They do great work in analytics. We also have Tyson Food, J.B. Hunt, and another real data company in terms of data brokerage, Axiom Corporation. I was very fortunate to be able to work for Axiom for 10 years in their data research and development division. And so I can really sympathize. When I left in 1995, we had 825 people whose job was to do ETL on customer data. And however, for Axiom, it was a business opportunity because it was all these other businesses that needed to integrate their data, couldn't do it, and so they threw it over the wall to Axiom, and they had all of these people, had some very good tools for the time as well to do workflows, to do the ETLs, and to integrate. So again, I'm not from Walmart. I buy most of my stuff from Walmart. We have a saying in Arkansas that if you can't find it at Walmart, you don't need it. Right? So what I decided to do was I wanted to talk a little bit, having been associated with this for some time. You know, Young Lee and Leo Pepino, Jim Funk, and Rich wrote a great book a few years ago called Journey to Data Quality. And it's an excellent book. I have the privilege of directing an information quality graduate program at the University of Arkansas at Little Rock, where I'm a professor. And that's required reading. I teach a Principles of Information Quality course every semester. And that's a required reading for that course because it really gives you the background of how this came about. So I thought then that I would play off of that and talk about the journey to where we are now. And, you know, as you get older, it's important to know where you are at any point. Sometimes you wonder where you are, or, you know, where you left your keys or where you parked your car. So this is sort of how we got to where we are here today in this conference. So again, quickly, my background is that I'm the Axiom Chair of Information Quality at UALR and the Director of the Graduate Program. And then I'm also here as a sponsor, co-founder of a company called Black Oak Analytics. And I spoke a little bit about that this morning. And then previously, as I said, I worked for Axiom Corporation and helped in their data research and development. So, so how did we get here? So this is a little bit out of some of my classes that I teach. Now, I know Young Lee likes to go back to the Rosetta Stone, but I don't quite go that far when I look at the history of information and data quality. So here's kind of how I look at it. And so which one of the, yeah. So I've divided these charts up into two parts. So one is the actual implementation in very gross block form of an enterprise. And then there's also the logical structure, what we call the enterprise architecture of how it was designed. And so we can see all of this is really sort of an evolution, if you will. And I like to say the starting place, is, as you mentioned, is data warehousing. So this was the first time that the idea of putting together all of your information assets in one place sort of took hold. And even though it did bring great rewards, I have to say that very early on, it was almost totally a failure to do that. So what happened, it was a great idea. People wanted to put all the information, and of course this was only the operational data. At that time, they really weren't bringing outside data. To do better decision making, which they eventually were able to do. But the big stumbling block was when they tried to do it the first time, as we say, it was just all a bunch of crap. Nothing matched. None of the schemas were the same. They had all these kinds of problems, and so there were huge problems. So this is when we really recognized the problem of information quality. And again, it spawned many great businesses to go in and basically just do data cleansing. So the next step, though, was, okay, let's try to prevent some of that. As you mentioned, we don't want to keep paying people to clean up the stuff all the time. Let's go back. And so we borrowed something from total quality management, which was already well underway at that time, that had really revolutionized manufacturing. So one of the principles of TQM is you have to do root cause analysis of your defects and go back and find out what's causing them. And so this was sort of the next phase to say, well, we can clean up the lake, but we need to go upstream and clean up all the streams that flow into it. And so that seemed like such a good idea that why not extend it? And this is where we really have to tip our hats to MIT, work that Stu Madnick and Rich and others did early on. And that was to say, this is actually a great model. If we think about information systems like manufacturing, we can just bring over all of the TQM, or most of it, into information quality, right? If you think of you're ingesting these raw products, this raw data, I'm processing it through the factory of software and systems, and the idea that Rich was very instrumental in promoting was the idea of managing information as product. So one of his seminal papers is about managing information as product and bringing this whole paradigm over. Instead of TQM, it was total data quality management. So we inherited so many things: quality assurance, quality control, continuous improvement, all of those things that the masters of quality management, Deming and others, had developed through total quality management. Now, up to this point, though, one of the big problems is that this is all retrospective in the sense that information quality professionals typically got called in after the fact. All of this is in place. And so it was the next phase in the evolution of information quality was to say, well, we need to bring in more design into the actual system. So as Deming and Crosby would say, we want to design quality into the process. So there was this reaching up now into the enterprise architecture to look at least the information architecture part of it. And so, can we actually, we find oftentimes when we're doing information quality consulting that it's not so much that the data are dirty, often, although it really often is, but sometimes the architecture simply won't support what they're trying to do. So oftentimes it's poor quality of information architecture. And so again, if it's true for the information architecture, then maybe we should look at the whole thing. So this is kind of where we are today. And this is the recognition that, this MIT has been a proponent of this for many, many years, and many other practitioners have been trying to tell organizations, information really is your fundamental resource. It's really one of your most important assets that you have. You shouldn't ignore it. Organizations often thinking of information as just a commodity. If I need data, I'll just go buy it. But now we see that recognition, and so there's two things that have come out of that. And again, we really need to thank MIT for their work in this. So one is, how do I manage information at the enterprise level? And the answer that's emerging is data governance. But we need more than data governance, and that is we need leadership. You can't solve everything by a governance council. You need someone with vision and leadership to develop a strategy around it, and that's where we come up with the chief data officer. So these two kind of go hand in hand and have historically kind of brought us to where we are right now, I think. Now, it's sort of like capability and maturity model in software development, right? Not everybody is here, obviously. We still find many organizations at different points along this journey, But more and more we see a convergence at this end. And I know I go to a lot of data governance conferences, and every year, like this conference, there's more and more people are really understanding that this is where we need to go. We really need to bring information under management at the enterprise level. So sort of where we are now then, I would say that we are kind of in this age of data governance. It's pretty well recognized now. There's more and more people adopting it. We've passed the tipping point on this. I know many years ago it was a hard sell to go in and talk about data governance, and people would say, no, that's just another burden on my back. I don't want anything to do with it. People were still feeling like they really owned their data within their department, and that was it. So we're kind of past that point. So we're recognizing it's really a key source and that we really need to manage it at the enterprise level, which we're beginning now to evolve data governance. It's not fully formed, but we do now understand what most of the moving parts are. We know that we need to have a view of all the information assets. We need these data dictionaries. More importantly, we need these data glossaries that sort of unify those schemas. We need central reporting of information quality issues, trouble tickets for data. We need sort of a one-stop shop for everything that's information related. For example, one place that everyone can go to understand what are all the regulations and constraints about the different data sources or data stores that are in the enterprise. So in some ways, data governance is really about communication of all these things and about control of them, communication and control. Another components that are evolving is, to your point, master data management, of slowly bringing in some of the key sources and bringing them under central management to get these so-called golden records. Typically, the first one to come in is customer. For some companies, it's product. And so we're beginning to see what are the different components, and we have lots of tools out there to help us now. I know Calibra is here, IBM is here, Informatica. They all provide tools that assist in doing these different parts that we recognize now as being part of data governance. However, we also now are recognizing, and this is the reason that we're all here, that it needs leadership. Data governance is a program, but we need a person. We need a representation of the information asset at the highest level in the organization, at the enterprise level, and that's what we've been calling the Chief Data Officer or Analytics Officer. Maybe there are other acronyms for it, but this is the one that we have been focused on. So, and the reason is that, you know, companies are really finding that they're really competing through information and not so much through technology. We've somewhat seen a commoditization of IT, not totally, but it's certainly not been, it's losing ground as the primary driver to information. So there are a lot of things, a lot of reasons we need the CDO, and there's a lot of things that bother him, right? So one of the #1 reasons for data governance and for a CDO position is regulation and compliance. There's just more and more every day there's regulation and at the federal, state, municipal level around the use of information, and there are often heavy penalties and fines for not being in compliance with those. Then, of course, trying to monetize or make money, and so there's a couple of ways to look at it. One is sort of the value side, the creation of value, new value, and then there's the avoidance of cost through risk management. So these are two other primary drivers now for data governance and for CDO, and that is to try to get more value out of your information and to avoid losses through risk that can be mitigated. And Alex Bork has a great book out on that about total information risk management. And then, of course, as we talked about our first speaker, Alex, this morning, this whole issue of system security, network security, all of these being on the front page of the paper, being on CNN as the latest victim of leakage. Another thing is that our customers are getting a lot more demanding about communication. And so just as we've seen an evolution in the recognition of the need to manage information at the enterprise level as an enterprise asset, we're seeing that customers are demanding more attention being personalized. So CRM is really becoming, is transforming as well from to one size fits all. And I know when I was at Axiom, we had a lot of focus on segmentation. So that was the latest thing of, had a product there where we would segment customers. But now it's really being driven down to the individual level. What customers want, they want to be recognized as me and what I want and what my preferences are. If you don't recognize what products I already have or what I want to be communicated about, that's becoming a very competitive advantage for companies that are able to do that. And then, of course, part of that is being driven by the fact that many customers are using these unstructured social media types of Twitter, as was mentioned earlier, Instagram, Facebook. And so there's becoming more of a need to integrate that into the operational structured kind of data. This is a different kind of data. There's a great article coming that just came out in the Journal for Data and Information Quality about this user-generated data and looking at information quality because it's different than operational data. Sales transactions were created in a structured way because we knew that they were going to be used a certain way in the company, but people who make Facebook postings don't have that in mind, right? So it may or may not be relevant at all to what the company is interested in. So it's the information quality and especially information content and determining information content is a big issue with the unstructured, especially social data. And then big data, I hesitate to use it, people don't like this word anymore, but it has changed IT. Big data as a buzzword is going to go away, but its legacy, I guarantee you, will live on for a long, long time. I want to talk a little bit about that. And then big data has driven cloud computing, which is just a natural consequence. If you're really going to use the big data technologies, which rely on distributed processing, not many people, at least at this time, want to set up distributed processing data centers. So it's much more convenient to use that as a utility through a cloud, whether public or private. And then mobile computing. And so we talk about data science, but there's actually a great trend toward moving data science out of the middle. The data scientists are doing great jobs to do analytics, but what companies would really like to do is push the slicing and dicing of information out to the user on a mobile app so that they can look up and answer the questions that they want to get answered directly rather than having to go through a middle layer of data scientists. So these are some of the things that we see happening and some of the things that, and of course mobile computing, I noticed an interesting thing, how acronyms change a lot. My space, I've been in MDM for a long time, Master Data Management, and so I saw, wow, there's this great article on MDM that came across on one of my listeners, and I looked at it, and it was mobile device management. So this is one of those things that has changed, so it shows how much importance this is getting. And of course, I don't need to go through all the Basel and the Sarbanes-Oxley and all these things that you're very familiar with, that these drivers around the regulation. And let me talk a little bit more about the interaction. So again, customers are changing. Again, everything is going online. They're guided by online reviews. They're comparing prices and services. And this is the one I think is the one that we really need to begin addressing, and that they're beginning to communicate with you through lots of different channels. So I read, there's an Aberdeen article that's out recently that said on average customers are communicating with companies over 9 different channels. So that's a lot of communication channels to manage. And they're, as I mentioned earlier, demanding that more individual attention and control about how you market to them, how you interact with them. So big data, again, apologize for keep using that name, but I don't know what else to call it. And you know, I think of 4 use cases. And again, I look at everything in a historical perspective. The original use case for big data was you just had big data. There was just too much data to process on traditional systems. Use case number 1, I want to index every word on every web page on the internet. It's just too big for a relational database model. But then, once people began to use this and had the ability to process large data, then another thing happened. They said, you know, with more data, I can get deeper insights, the so-called data science. I can look at it. I can find out things that were a lot less apparent when I looked at last year's data. What if I look at 10 years worth of data? So maybe my system is up to my current capacity to do transactional processing for my current customer database, but what if I want to go back 10 years and put it all together? What if I want to unify it with social data or other external data? Now it really is big data, and so there's another use case for big data, and that is putting a lot of data together to get deeper insights. And so that really opened the door for large-scale data mining and business intelligence. And the third use case, as I already mentioned, really is the social. You have to have the big data technologies for social data, because even though only a small percentage may be relevant to you, you have to filter through an immense amount of it to get it. So another big driver, third use case for using big data, are people who want to integrate social media like Twitter into their operational data. It requires a lot of processing to be able to do that. And as I just said, and so this is again one of the primary drivers for cloud computing, because now we have all these people wanting to use the technology. To really use it effectively, you need distributed processing systems. Most data centers are not set up for that. It's much easier just to rent what you want on the cloud. Now, one of the points I wanted to make about, I said big data, by the way, this is all my opinion, is a buzzword that's going to go away, but here's its impact, because I'm white-haired too. I've been in this game for a long, long time. I actually used to be a chair of computer science, and one of the things that we struggled with was parallel computing. And my first language was Fortran, by the way, and they came up with another version of that called Parallel Fortran, and then they had Parallel C, and you name it. There was a parallel version, but it was a failure. Parallel programming languages, by and large, have failed because programmers don't think in parallel. We all think algorithmically and step-by-step processes. So I see the greatest impact to the big data technology has been that it has opened the door to massively parallel processing without having to have a staff of PhD programmers. So you give me a good Java programmer that does standard Java, I can get him running on Hadoop MapReduce in 3 or 4 weeks, and within 6 months he can be a really good programmer in that. One of the big impacts of big data has been that it has opened up parallel processing by putting it down in a mid level that's sort of underneath the programming level, because one of the big paradigms of the big data technology is that we're moving the processes to the data rather than moving data to the processes. It reminds me, you know, one of the big breakthroughs for computer science was John von Neumann. Back in the very, very early days of computing, you had the hardware and you had the storage, but the programs were wired through plug boards outside, external. And it was von Neumann's idea to say, put the program code in the memory as data. And so now we just take that for granted that the programs are stored in memory along with the data, and the operating system is what keeps them separated. We've had the similar kind of breakthrough with the big data technology now to sort of, we're using now distributed storage systems like the Hadoop distributed file system, where processes are actually now embedded into these are hardware processes, into the data storage. So the architecture is all mixed together, storage and processing together, so you don't have to move the data from one system to another to process it. So, the computers are faster, storage is bigger, it's cheaper. All of the big data technology software is open source, free, and even many enterprise level. Cloud computing is very attractive. We see software as a service, data as a service. So IT is changing, and we're not going to go back. I don't think we're ever going to give up this ability to do massive parallel programming, no matter what size or what scale data that we're going to process. So, so quickly, what's coming, my vision is not as far out as many of the people that have been speaking here today. I'm just looking more at what I'm seeing from where I stand in our business. And so some of the emerging trends is that data governance is here to stay, and it's going to get more sophisticated. We're going to see more transformation of customer relationship management down to this individual level. And again, I predict that we're going to see the adoption of these big data technologies. Even though we're going to quit calling it big data, we're going to use those technologies, and those are going to become the norm for IT. One reason I know that is I teach in a graduate program. That's what all our students are learning now. So that's the people you're hiring. So, you know, this is like the old Apple strategy. You get them using Apple in the classroom, and then they want to buy apples when they get to the company. They're using the big data technologies in their classes, and so it's sort of like what happened to business with BASIC, right? They used to teach people BASIC, so they went out and wrote all their programs in BASIC. So we're seeing the same thing with Hadoop and Spark and these other kinds of technologies. I'm sure those will change, but it's going to be the norm. And again, we'll continue to see a growth in cloud computing. And for the data governance, again, we're moving toward universal adoption of data governance. And I see the future there is that right now it's at the enterprise level. The next step is to move it across enterprises. So there are many systems, for example, healthcare, right? So you have several hospitals, several clinics, several providers, several insurance companies. They're all in this ecosystem within a region. They're each individual enterprises, and they each have their own governance, or hopefully at some point will have their own governance. There's sort of a meta-governance above that of how are they going to interoperate. And the master data management systems will become more sophisticated, maybe incorporate some of these automatic ingestion techniques. But we already see that they want to be multidimensional, taking in lots of different entities within the same system, multi-channel, taking information in from all these different channels, like the 9 different customer channels. Multicultural is a big challenge, not only just in character, you know, Chinese to English, but simply in the way that information is managed in different cultures, and hierarchical. So many of these are nested. We have addresses for customers and customers within households. So we have hierarchical arrangements of entities that we want to keep track of. And so more and more MDM systems will be built that will deal with these. And then I think even we're going to go into master metadata management, because the next step, you have many master data stores like customers, products. What about the interactions between those, the matrix of interactions? So those are going to become part of the data governance. So as I said, one thing we're going to see is more trying to extend data governance to many enterprises, sort of a meta-level governance, if you will, to promote data interoperability. And then the transformation of CRM. Customers are really demanding that, that companies honor their preferences and how they want to be marketed to on an individual basis. So we're going to need more sophisticated tools to govern that information. And again, I talked about the number of channels increasing. So again, I think big data will be the norm. We're not going to want to go back to only running relational systems. We're going to really fall in love with this ability to do parallel processing without having to learn parallel programming. It's just a very compelling technology once you start using it. It's a different way of thinking about it, but it really has changed IT systems. And as I pointed out, as more people get trained in this, then you're going to see it's going to be easier to implement and maybe your only choice at some point. So I want to wrap up there so we can have time for both of us to answer questions at this time. So thank you.
We have 20 minutes, and just like last time, we have speakers. If you want to ask questions, just raise your hand, and we'll bring it to you. Okay, and maybe Mike, could you come over here and answer? Okay.
Hello. Very interesting, two very fine presentations, both compelling, and yet there seem to be maybe some conflict here. I was wondering, maybe not. Is the global data model a fallacy? Are we in the age of data governance with universal data dictionaries? Are the two of you speaking about the same topic?
Well, let me give you a quick vignette. So 1 million years ago, I was the Chief Technology Officer for Informix. The new CEO of Informix came in, and the first staff meeting, he turned to his human resources vice president, said, "How many employees do we have?" And the HR person said, "I don't know, but I'll go find out." Staff meeting the next week. The CEO turns to the HR person and says, "How many employees do we have?" And the HR person says, "I don't know, and I can't find out. There is no answer." And the reason was Informix operated in 58 countries with 58 different sets of rules for what was an employee, rules for who's a contractor, who's not a contractor, and so forth. There is no global data model for employees for Informix. They could not build one. So I think, that in general, it's impossible. I think the second example is, suppose your enterprise can build one. So you have all these golden records. You now buy Company A. Company A has a different set of golden records, and now there's no global data model anymore. So I think acquisitions screw up everything. In the banking business, this is a huge deal, because when you buy somebody, you get a bunch of contracts as to what customers look like, and you can't change those. And so I think it's really difficult in large enterprises.
Yeah, so well, I agree. I think that's been our problem for a long time, is trying to get to this global model. I agree with that. However, I would say that, again, the new paradigm, and I speak a little bit in defense of the data lake here. I do agree that it certainly can become a data swamp, but it becomes a data swamp if you don't have data governance. So we must have data governance. We have to have all the information under communication and control. However, that doesn't necessarily imply that it's all in one big global model. As a matter of fact, one of the reasons that I think that we see such wide or increasing adoption of of the big data technology is it releases us from the bondage of the relational schema. So what happens if properly done, you do ingest these sources, but you still have to, there's no magic bullet. You still have to put in the work on the outbound, but by structuring on the outbound side, doing transformations and building specific data marts, it gives you a lot more flexibility because it's true, you're bound to find that you were wrong in your model or something has changed. But it's not the same investment that you had if you pre-structured everything on the inbound side. You can just erase that mart, sort of, and go back to your lake, if you will, and rebuild it in a different way. It gives you a lot more flexibility. So again, it's not a magic bullet in that it solves all the problems, but it gives you a more flexible way of approaching it.
Michael, going back to your Milwaukee experience, how do you deal with the tribal behavior, as we've seen, taste great, less filling? In your view, how do we deal with that very entrenched tribal behavior when we're trying to harmonize things?
I think business analysts have an insatiable demand for more, and they always will. And I think rightfully so. They can do a better job if there's more things to correlate. And I'm not sure what kind of tribal behavior you're referring to. I mean, they can do a better job if they have more data, and that's just plain true.
Well, and again, I would say that if you take that data and you have proper data governance in your storage system, then you can ingest lots of other data, but you don't necessarily have to integrate it in universally. Again, if it's going to be helpful to one application, you can build a data mart for that application that uses that. It gives you a way to sort of build a gradient of quality from raw data coming in to maybe sort of a silver level to, sort of like our sponsorships, right? Sort of silver and gold and platinum level data quality that everybody can have access to and build their applications that they want without actually having to undo, right? One of the 101 precepts, right, is don't do anything irreversible to the data, which is what we do all the time when we build these relational marts, right? We do the transformation on the front end and we put them in, force the data to fit the model, and then we build a warehouse where we pull it out of the operational storage, put it in another model, and by the time it gets into the warehouse, there's no way to ever go back to the original without starting all over again.
But none of this addresses that Informix had 58 employee golden records. And the big problem is 58. And country requirements, ... dictate 58. And you can have as much data governance as you want. You're not going to reduce those 58 golden records to one. I mean, it's just not going to happen. And what's more, your IT doesn't control the 57 countries that are not in the US. Some of these are independent entities who thumb their nose at you when you say, all I want you to do is rewrite your information system to conform to my golden records. I mean, I think they're just enormous political issues here, and I think it's laudable to chip away at them. But
yeah, we just
I
haven't
think
got to the meta governance yet.
adding another layer is just going to slow things down. I mean, the big problem, having watched companies try and put data governance into existence, it gets politically resisted because it slows people down. And this gets in the way of I've got to deliver a system in a month, and I don't have time to do it your way. It takes too long. So I think you've got, if you're going to make this happen, it's got to come down from the CEO with a huge, huge stick, because I think it definitely will slow everybody down and cost more money. And unless your corporations are willing to deal with the shrapnel that this generates, it's going to be a big issue.
So to build on that point, I'm over here. Yay. Other side. Yeah. Anyway, we are working right now in my company to elevate the master data governance for our North America and South America divisions. However, we also have divisions in Europe and Asia. So if we finally, and it's taken us 12 years that I know of, get master data governance in place, approved, everyone buys into it, and currently our CEO does, what do we do with the data that we receive from the other poles? So when we start receiving more data from Japan and Malaysia and Thailand and all of our places in Europe, when we try to incorporate truly globally to something that we've spent 12 years establishing for the Americas, I'm afraid that we're going to be, as someone mentioned before, immediately out of date. So how can we truly globalize our data without extensive manpower? And I know that we're all here to learn about CDOs, and that's one of the things that's floating around our organization, but do we need a CDO for one location or all locations?
Should ask Rich Wang that.
I think you've got everybody's problem, which is you're trying to integrate pre-existing systems that you didn't control and which exist and have got to be ex post facto integrated into, with other stuff. And I think, using traditional techniques, it's essentially impossibly expensive. And so I think, there's a bunch of new ideas that you should take a look at. Yeah, but I think using traditional techniques is not going to work.
Yeah, I think one that you might want to consider is data virtualization as well. So I don't know to what extent these are disjoint, or maybe that's the issue. But it's not necessary to physically put them in one system. There's a lot to be said. And now I think even the way a lot of people are building traditional data warehouses is through virtualization. So you rationalize the schema so that your operations, you have an API into the system that understands the schemas of the different systems and can do a consolidated query so that you're not necessarily forced in the position that you are trying to physically put all of these into one kind of a data system. So I would look at some data virtualization techniques. But it certainly helps if each one is already golden, if you will, and you do have these persistent identifiers associated with them. It still makes the whole operation a lot more, I would say easier, but it certainly facilitates the integration and the looking to see if there are duplicates across these systems.
Yeah, my favorite example comes from Citibank in the 90s. So at the time, they had a huge initiative, which is their large business customers, think IBM, wanted a single statement of their worldwide activities with Citibank. And so Citibank had about 500 demand deposit accounting systems, think one per country, well, more than one per country, checking account systems. There was no universal identifier across Citibank for IBM. And so you have 500 independently constructed, operational data systems, and no way to put, each of them has their own golden record, of course, but so no way to correlate the matching records, in the other 499 data sources. And so ultimately Citibank sent a letter to every customer saying, "Who are you?" Because they couldn't figure it out. And I mean, data integration is really, really hard. And I think do whatever you can with master data management, but I think it's not going to get you what you want. And especially, it's awfully expensive to retrofit existing operational systems to change their golden record structure. And I think I think we're going to be at this for a while. And I think all you can hope to do is keep the problem from getting any worse.
That's definitely a hard problem. That keeps us in business. I like that.
This is an interesting pairing of talks. Really enjoyed it. But I'd like to put in counter to each other the concept of meta enterprise governance or meta governance and the problem of the global model that you were talking about, Michael. Because in such areas as in financial services, where it's very hard to introduce a global model, even a local model is highly challenged. From the regulatory communities, both at the national and at the supranational level, there's tremendous desire to simplify, to find some way of getting to a model so that there can be analyses, for example, in the areas of systemic risk and understanding that. And one path that's being taken is to impose a model, an ontology or a taxonomy representing, for example, complex securities. I wonder if you both might be able to comment how those play into governance, and are those means of getting to a more successful kind of global model or broad-based model, or are those subject to the same kinds of challenges that an enterprise would have in trying to build it?
Well, I think we have some semantics here. So you mean global model? I mean, yes, you want to have a global understanding, but when you say global model, if you're talking about one schema, one grand schema, I agree wholeheartedly with Michael. That's just unachievable. I've seen so many people try to do that, but it's the same way we do programming, right? So we do object-oriented programming now, and so we write a module, it can't be more than 50 lines long. So master data management is not a global model. Master data management is simply bringing under control one key entity. So master data management for customers is something we all strive for. It's hard to achieve, I agree, but it's only one segment, only one slice. So we're not tackling in master data management of customer systems, we're not managing financial instruments or those kinds of things. There's another model, there's another way to get to that. You want this model to be interoperable, and that was my point in the slides, is this is sort of the maturation of data governance in the sense that where we are now is we're taking these thin slices and say, well, we got to get customers under control, so we're going to do that. And then we got to get products. So the next level is what are the interactions between those? That's another layer. And it does get more complicated, but what Albert Einstein, you have to make everything as simple as possible, but no simpler. There's only so simple that you can get things down to in a complex organization.
One last question.
Do I get to respond? So I think if you look at the two most successful examples of this data integration, the first one is Walmart. So Walmart has ordered 60,000 suppliers, and Walmart has enough throw weight that they say to any supplier, you want to sell to me, you'll use my golden records. And they have enough throw weight that they just impose their will on anybody, anybody who wants to sell to Walmart. So if you're a big enough fish, you just say, here's the way I do business, the heck with whatever you want. And that works beautifully. And the U.S. government can do the same thing. IRS and HIPAA can say, here's the way we do things, screw you. The other successful example is the airline business. All their reservation systems, in fact, interoperate. None of them are the same. There's no golden records, but there's only about 10 of them. And so they just do it at scale 10. So I think those are the successful examples. I think doing it at scale 100 or 1,000 through standards is going to be unbelievably difficult. I'm hard pressed to find an example of that working. But maybe I don't talk to enough people.
Yeah, my name is Lindsay Anderson. I run the MIT Sloan CIO Symposium. And so I'm interested in the role of the CDO in the enterprise. So does the CDO, is he or she reporting to the CEO, the CIO, somebody else? And a company that doesn't currently have a CDO, how do they go about making a decision that, hey, we need to have a CDO, and what kind of criteria do they use in selecting someone for that role?
I'll defer to Richard.
I'm an authority on that. So the answer is that you pick. Okay, we have done quite a bit of studies, and CDO turns out reporting to all kinds of CFO, CXO. Okay, and so you pick depending on your organizational context. And the only thing, CDO must work out well with CIO. If ideally they should be parallel to each other. Otherwise, the CDO's career is over in 18 months. And unfortunately, a lot of CDOs that I have seen is reporting to CIO, which is what I don't like, but that's the reality. So that's the first part. And in terms of their roles and responsibility, if you don't have it, ask Jamie Popkin or Joe Bogas. Is Jamie here? Yeah, Jamie is here. It's his Gartner group. They have a set of rules and roles and responsibilities, all kind of things, and they're doing conducting a major study. And what's the third question, Lindsay? There's another third question to ask.
What sort of criteria did one use to select
That's a go-to Gartner group. They can help you. Yeah, they specialize. They just charge you a lot of money. With that note, I think we run out of time. Lunch is very short, and I want to give Robert Imparato, Robert Lardner.
Yeah, just
wait. I have to have further opportunity to give the words to Mike. My God. Thank you so much. I'm going to quit MIT and work for him. And John, on behalf of, you take this one? You can change the name though.
All right, thank you.